Okay, good morning class. So today we're looking at the grade 12 cycle test 2 that was written in 2022. The question paper and memo can be found in the description box below. So in question 1.1, we are given that 6 cos 2x plus cos x plus x equal to 0. Show that the given equation, which is this equation, can be written as. So where do we start? We know that we can change cos 2x. Cos 2x or cos 2 theta can be written as 1 of 3. Can be written as cos squared alpha minus sine squared alpha. 2 cos squared alpha minus 1. And 1 minus 2 sine squared alpha. Which one of the three we're going to use? It's the second one. Why? Because of what we have here. If this had read sine of x, then I would have changed it to the last one, which is 1 minus 2 sine alpha, 2 sine squared alpha. If this had read cos alpha sine alpha, cos x sine x, or sine x cos x, then I would have used cos squared x minus sine squared x. Okay. So as we said, we're going to use the second one. So it's going to be 6 into 2 cos squared x, 2 cos squared x minus 1 plus cos x plus 6 is equal to 0. Get rid of the brackets. So it's going to give me 12 cos squared x minus 6 plus cos x plus 6 is equal to 0. This bracket is supposed to have been there. No? Add like terms, that cancels. So you're left with 12 cos x squared x plus cos x equals 0. We take out cos x as a common factor. I'm left with 12 cos x plus 1 equals 0. Okay? Okay, the next question, it says hence. Hence means the same as use the previous calculation. So say we didn't get the solution, you must use that anyway. Okay? Morning. Hence, you tell the general solution of the given equation. So we're going to apply the 0 factor rule. So I say cos of x is equal to 0, or 12 cos of x plus 1 is equal to 0. So if this is 1 minus 1 is 0, I take it to the graph. So that's what the cos graph looks like. Where is this cos? It's normally 360. Where is cos 0? At 90 and 27. So you can write it as x is equal to 90 plus k times 360, or x is equal to 270 plus k times 360. Or, since it's the repeated solution every 180 degrees, I can say 90 plus k times 1. And then we say 12 cos is equal to negative 1 over 12. So we then work out what is r cos of 12. So r cos of 1 over 12. You will answer 85,22. Alright. So the questions we ask ourselves, in which quadrant is cos? Negative. You note that I haven't used the negative. So cos is negative, all stations, 2, clear 1. So it's in quadrant 1, 2 and 3. So we go to quadrant 2. X is equal to 180 minus 85.22 plus k times 360. So you say 180 minus answer. So they give you an answer of 94,78 plus k times 360. Or quadrant 3, which is x is equal to 180 plus 85,22 plus k times 360. Is that correct, people? 85 gives us 265.22 plus k times 360. Do not forget, right, k is an element of integers. That suffices for all three branches. Okay. Any confusion here? It's a distance question. So here we are told that in the diagram, DC is a vertical pole, BD and DE are cables with equal length B, okay, so it's indicated here, B, E, and C is in the same horizontal plane. We're assuming that's on the ground. We are then told that B is 2x meters and DC is x meters. The angle of elevation of D from E is theta. So this angle here is theta. Okay? And then we are told that DBE, which is this angle, is 90 minus theta. Then we are told that D angle BDE is alpha. So the question says, the first question, I'm going to move this up. The question says determine alpha in terms of theta. Alpha in terms of theta. So looking at this triangle here, I'm going to draw it here. So that's going to be D, which is alpha, that length is equal to that length. This is 90 minus theta, this is B, and this is E. So you must make alpha the subject of the formula, not so. So we're going to say that this is 1.2.1. We can say firstly that angle E is going to be 90 minus theta. Why? Angles opposite equal sides. People, do I have to give a reason here? No. Since we are busy with heights and distance with trig, or we are not busy with Euclidean, so the reason is not required. Unless the question says with the reason. Okay. So if this is also 90 minus theta, so therefore alpha is equal to 180 minus 90 minus theta minus 90 minus theta. And why is this the case? Sum of triangles. This triangle, DBE. Again, you don't need this reason. Okay. So it's going to give you an alpha, or you could have said alpha plus 90 minus theta plus 90 minus theta is 180. So 180 minus 90 is 0, so that cancels. So plus theta is going to be 2 theta. So alpha is the same as 2 theta. So alpha is 2 theta. You all okay with that? Right here. Let's go to the next question. The next question then says, show that DE is equal to x over sine theta. DE, where's DE? So you see in this triangle here. So DE, I must pick up this length. Let's just take this off here. 1.2.2. If you look at this triangle here, note that I always write it out so that it makes it easier for the learner to see, or for me to see. Okay. There's your angle theta. So you must pick up DE, and you must pick up X, as you can see here. So which trigonometric function is opposite in hypotenuse? Sine. So sine of theta is equal to opposite, which is X over D. Cross multiplies, that goes up, this comes down. So DE is equal to X over sine theta. And that's what they wanted. Okay? So that's going to be X over sine theta, which is the same as this here. Okay? Let's look at the next question. Alright, so it says hence. So based on your previous findings, or the previous question, or the answer of the previous question, show that the area of, okay. So we're going to work out the area, people. Area of triangle DBE. DBE. So it's this triangle. So how do you calculate the area of a triangle? Using in a non-right angle triangle, we're going to use a sine and not so. So we're going to have two lengths and the included angle. Or I could have used these two lengths and this included angle. Or I could have used those two lengths and this included angle. Because I have all the lengths and all the angles here, I can go anyway. Not so. It will result in the same solution. Alright, so to 1.2.3. The triangle looks again like that. There's going to be 2 theta there, so it's D, this is X over sine theta, same X over sine theta, and this was B, E. So those are the two lengths that included. I could have written 90 minus theta as well, if I like. So the area is going to be half BD times DE. Sine of angle D. Okay? So it's going to be half times X over sine theta times X over sine theta times sine 2 theta. So sine 2 theta can be written as 2 sine x cos x, not so. So it's going to be half times, that is going to be x squared over sine squared theta times 2 sine theta cos theta over 1. Of course the 2's cancels, the sine cancels with one of those signs. So what are we left with? We are left with x squared times cos of theta over sine of theta. People, we know that sine of a cos is 10 and cos of a sine is 1 over 10. So this is going to be x squared times 1 over 10 theta, which is the same as x squared over 10 theta. We could have gone from this straight into that. Okay? And we just proven what they wanted us to have proven in that case. Okay? And then the last question says, if the area of this triangle, DBE, the area we just worked out, if the area of that triangle is 16 centimeters squared, and theta is 25 degrees, determine the length of BD. Determine the length of BD. Where's B? This length. What is omitted? Is x omitted? Yeah. So in other words, with this information here, okay, I could actually calculate x, or the value of x is, because BD is 16, so 16 is equal to x squared over tan of 25. That naturally over 1, so I cross multiply, so x squared is equal to 16 tan 25. So I work that out, so 16 tan 25. 7,46, the square root thereof. Normally when I go square root, I go plus and minus, because why? X referring to length, I'm only going to use the positive solution. So x is equal to 2,73 centimeters. But I haven't answered the question. The question was to calculate the length of BD. Now BD is known as x over sine theta. So BD is going to be x over sine theta. So what do we say? We say x is 2,73 over sine of theta, which is 25 degrees. So this answer over sine 25 degrees. The answer 6,46. Is that correct? Okay. Any confusion there? Right? Let's go to question 2. A circle has the equation x squared. The circle has the equation x squared minus 2x plus y squared plus 6y is equal to 15. Okay, so we've got C, B, A, and D. Question says, find the center A and the radius of the circle. So to get it, to extract the center and the radius from a circle, or equation of a circle, it must be in the form of x minus a squared plus y minus b squared is equal to r squared. That's the form it must be. So what I do is I say x squared minus 2x plus a number. I'm going to complete the square. Alright, so it's going to be y squared plus 6y plus a number. Complete the square with is equal to 15 plus the first number plus the second number. Alright. So what is the number? To get this number, it's going to be b times a half, which is 1 squared. It's going to be 1. 6 times a half is 3, and 3 squared is 9. Alright, and there we got our perfect square trinomial. This is now going to give us x minus, take the sign of the middle term, the square root of 1 squared is 1, all squared plus y, positive 3, all squared is equal to 3. So what's the center of the circle, which in this case my a value is 1, the additive inverse, and minus 3, which makes sense, x on the positive and y is on the negative. And the radius, remember that is r squared. My radius is going to be the square root of 25, which is 5. In other words, that length is going to be 5, or that length is going to be 5, or AC is 5. Okay? 2.2. So that information is on the circle. Okay, I'm going to take this off. Question 2.2. The question says determine the coordinates of B and C. The x-intercept. People, how do you calculate x-intercept? We let y equal to 0. Just give me that equation and let's just calculate it. It was x minus 1 squared plus y plus 3 squared is equal to 20. The y-intercept with x equal to 0, or with x-intercept with y equal to 0, so I'm going to go with that one there. So x minus 1 squared plus 0 plus 3 squared is equal to 25. 3 squared is 9, 25 minus 9 is 16. So x minus 1 squared is equal to 16. To get rid of the square at square root, I introduce plus and minus. So x minus 1 is plus minus 4. They get over the equal sign. So x equal to 1 plus minus 4. So x equal to 1 plus 4 is 5, or x equal to 1 minus 4 is negative 3. Did I answer their question? No, they wanted the coordinates of b. So b is on the negative part of the x-axis, so it's minus 3 and 0. And c has to be the 5 and 0 mark. Okay. Look at the next question, 2.3. Determine the equation of the tangent to the circle at this point, D, which is 5 and negative 6. In other words, it's a line going through like it, touching at that point only. Alright, so to work out the equation of the tangent, we know that the radius is perpendicular to the tangent. The radius is perpendicular to the tangent. So we're going to work out the gradient of AD first. Okay, because we don't have 2 points on this graph, we only have 1. So gradient of AD is change in y over change in x. So it's going to be minus 3 minus minus 6 and 1 minus 5. So that gives me the answer of negative 3 plus 6. Oops. Over 1 minus 5. It's negative 3 over 4. Does it make sense? Yes. The graph is lying to the left. The tangent. The other tangent is only the radius. The gradient of the radius. So we know that the gradient of the radius times the gradient of the tangent will be negative 1. So it's negative 3 over 4 times the gradient of the tangent, negative 1. So the gradient of the tangent is going to be 4 over 3. We now say negative 1 divided by negative 3 over 4. Okay. So what's my equation now going to read? Y is equal to 4 over 3x plus c. So to calculate the c value on this line, we're going to substitute the point that's lying on this line. So we're going to substitute d, which is 5 and negative 6. Remembering that's an x and a y. So negative 6 equal to 4 over 3 into 5 plus c. So that's 20 over 3. Take it over, becomes negative 20 over 3. So 18 is going to give you a negative 38. Let's check if that's correct. This is C and not 5. So my equation now reads y is equal to 4 over 3x minus 38 over 3. Okay? See, any confusion there? We've got y is equal to negative, we've got 4 over 3. Okay. Let's go 3.4, 2.4, sorry. In 2.4, the question says determine the area of triangle ABC. Area of triangle ABC. This triangle. For 3 marks.
My apologies for the interruption. Umpile Dava, can you please report to the office? Umpile Dava in word 12 to report to the office.
Here? Oh. Okay, so do we know enough to say this is a right angle triangle? No. We don't know enough to say that's a right angle triangle. It's actually not a right angle triangle. Because this is going to give you 5, this is also 5, not some. And if I apply Pythagoras, then this is supposed to have been 5 root 2. But this is actually 8. Can you see that? So it's not a right angle triangle. So I need to use the sine rule. However, I need to know this angle here, which I don't have. But with this information, I got 3 lengths. So I can work this using the. How can we calculate this angle? We have 3 lengths. The cos rule. So we now say that this is 2.4. We know that BC squared, first write it out. BC, so you don't have to write it out. Is equal to AB squared plus AC squared minus 2AB times AC cos of BAC. So that's going to give you 8 squared is equal to 5 squared plus 5 squared minus 2 times 5 cos of BAC. Now I know some of you can just write cos BAC is equal to BC squared minus AB squared minus AC squared all over negative 2AB times AC. I can't remember so many things, so I just use the basic formula and manipulating from these simple, fairly simple. So 8 squared minus 5 squared minus 5 squared, I took that over the equal sign, then I'm left with negative 2 times 5 cos of this angle. So I divide by its product here, which is negative 2 times 5 I put over it in 50 in the negative. Well, because of BAC. Alright. So angle BAC is simply going to be arc cos of 8 squared minus 5 squared over negative 2 times 5 times 5. Gives you 106,26. Which means to say it's obtuse. Is that correct? Otherwise, if you had worked this out, you would have seen you got the negative angle. And you take arc cos, you get the, and you drop the negative, and then you take it into the second quadrant because the cos was negative. You can't go into the third quadrant because in the third quadrant is an angle greater than 180 but less than 270. So it has to be in the second quadrant. So therefore now the area is simply of BA times AC sine of angle BAC. So it's going to be half 5 times 5 or 5 squared sine of 106,26. It's half times 5 times 5 sine the angle. Is your answer? Well, was there an easier way? Okay, what was the easier way? Sorry? Of 8 times 3. This makes sense of what was here? Oh my word. Much easier. Sorry, I didn't see that. You see here, if you drop a line perpendicular here, then you got a right angle triangle anyway. So it's going to be area is equal to half base, which is BC, times perpendicularity. So it's going to be half BC, which is 8, times the perpendicularity. You see here, this is my 0 on your y. Not so. So if that is minus 3, so this distance has to be 3. And a half times 8 is 4 times 3 is 12 years. When I did the memo, I could have showed it, but there's just a bit too much on this diagram now. Okay? Both ways you get 3 more. Do you see the benefit of sorting out these things? Or seeing these things? It will save you a lot of time. And imagine I made a mistake here somewhere. It will cost me also. Okay? But okay, that's how it goes. Let's go with 2.5. In question 2.5 we are told, given that another circle, x minus 1 squared plus y minus b squared is equal to 1, touches the circle with center A in one point only. Determine the value of the values of b. Okay, so looking here, the center of this circle, okay, would simply be 1 and b, with a radius of 1. Okay, so if you do the comparison and see here and here, what do we notice? It has the same? It has the same x value. The centers have the same x value. Which means to say, that circle that they are referring to is probably the small circle. Okay? The radius of 1. So it's there. And you could have put here as well. Not so. With that point being the same x value as this point here. As you can see, it's 1. Okay? So the radius of this circle from there to there is what? 5. And from there to there? Also 5. Not so? What is the radius of the circle? 1. So what is this length from there to there? 6. So I say negative 3 plus 6, what do I get? Sorry? 3. So that center is actually 1 and 3. Which makes my b value 3. You see that? Let's go to the other side. You see? It's touching 1 point only. So it's, as you can see, it's that point and this point here. What is this length? 5. And the length from there to there? 1. So what is that length from there to its center? 6. So if I drop negative 3 minus 6, negative 9. So the center is going to be 1 and negative 9. So therefore B is 3 or B is negative 9. Okay. Of course, if they had given you minus A and your B value was given as minus 3 or positive 3, yeah, your B value is minus 3, then the two circles would have lied here and there. Why? Because they had the same y value. Okay, you guys understand? 2.5. Let's go to question 3. The boy was waiting all her life to get out of this question. No? The sketch below shows a graph of f of x is equal to x to the f of x is going to be half to the x, g of x, you know that g of x here, is equal to a over x plus b plus b. B is a point of intersection of the asymptotes, which is this point here. Then we are told that the g, the asymptotes of g. A is the y-intercept of f. It's also going through the asymptote thing. The graph of g passes through the origin, which is there. AB is parallel to you. x-axis. Okay. First question. Write down the equation of the inverse of f in that form. So we do start. What do we do for the inverse function? Interchange x and y. So then x is equal to half to the y. So what do we do now? We apply logs. So therefore y is equal to log x base a half. And this is the inverse of it. This could also have been written in the form of, okay, remember? Negative log x base 2. Now, because of that half there, I'm bringing the negative. Okay. Remember that, huh? So the transformation question, if that comes in, it's always around that confusion. Okay. 3.2. We are asked to write down the domain of the inverse function. If we're looking at f, what is the domain of this function? X is an element of R. Not so. What's your range? Y is greater than 0. So if I redraw this graph, we'll take its inverse into account. So that is A dash. So if x is 1, y is half. And if x is a half, if x is a half, y is 1. So the graph is going to look like that. Okay, the question was not to draw the inverse graph. No? So what is your domain of this function? X is greater than 0. That is one way of looking at it. Otherwise, I could have just said, okay, the domain of the function is x an element of R. The range of the function is y is greater than 0. So for the inverse function, the domain is going to be the range of the function swapped around, which would be x is greater than 0, and the range of the inverse function is y is an element of R. You could have done that as well. Or if you knew it out of your head, you just write that down. Whichever way you decide, okay? Whichever way you feel comfortable in doing. But do something. Okay. Otherwise you tell yourself, too much options, just leave it out. We got 3.3. The question says, determine the value of the values for x for 4 times f of x plus 1 is equal to the root of 2. Solve for x, no? So, people, f of x is what? Half to the x, not so. So what's f of x plus 1? Half to the x plus 1. So it's 4 times half to the x plus 1 is equal to the root of 2. Okay, so what do I do now? 4 can be written as 2 squared. Half can be written as 2 to the negative 1 raised to x plus 1. And 2 can be written as x 2 to the half. Not so? And I multiply, okay, first sort that out. So it's 2 squared times 2 to the negative x minus 1 is equal to 2 to the half. When you're multiplying and base are the same, what do we do? Add the exponents. So it's 2 plus minus x minus 1 is equal to 2 to the half. When bases are the same, exponents are equal. So 1 minus, so therefore 2 minus 1 is 1 minus x. It's equal to, you see that basically the same. So the exponents are equal. So x is then equal to r. Okay. Beautiful. No? Then again, all questions are beautiful. Yeah, I made mistakes now. So check if that's correct. I can't say, let me get the off. So it's 4 times. It's correct. Oh, it's 3 over 2, yeah. Okay. People determine the range of G. What type of graph is G? G is your hyperbolic graph. No, your hyperbolic graph. What is range? Range is all possible y values. But we know what's the equation of this line here? Y is equal to 1. How do I know that? John 8. And we know that is your y-intercept of it. So what can we say? For the range is going to negative infinity, positive infinity. That's your hyperbolic graph. No? So we say your y is an element of R and y is not equal to. Okay. Go to the next question. 3.5. 3.5. If h of x is equal to if h of x is equal to x plus 3 is the equation of one of the axes of symmetry of G. Determine the coordinates of B. So let's take this off here. So here we are told that if h of x is equal to x plus 3 is the equation of one of the axes of symmetry of G. So G is going to be this point. So y is equal to x plus 3 or h of x. No? Okay. But we know they want the coordinates of B. But what do we know about B at this point already? We know that your y value is 1. So you'll substitute that into h of x. So you'll sub B into h of x. Remembering that's an x and a y. H of x is a y. So 1 is equal to x plus 3. You get over, so x is equal to minus 2. So therefore B is negative 2 and 1. Yo, this is a nice question, man. I could have asked you this in your exam. Huh? No, your paper's printed already. Why do you think I make jokes? Everybody think was the math teachers don't work at the school. It's either an X or a tick. Whenever we mark and then they say, yes, you guys have easy lives. So the X is either X or a tick. No? So we don't really work at schools there. 3.6. Hence determine the equation of G. Right, so we got P, we got Q at this point. So your equation reads y is equal to a over x. Remember this is minus 2, so there must be a plus 2 at the bottom. Plus 1. And we check, okay? X plus 2 can't be 0, so x can't be minus 2. Hence, your asymptote here. Okay? People, to get the value for a, we're going to substitute. The point is lying on this graph that we haven't used yet. And of course, it's going to be your 0, the origin, which is 0 and 0. Remembering that's an x and a y. So 0 is equal to a over 0 plus 2 plus 1. Take that over the equal sign. Negative 1 is equal to a over 2. So a is negative 2. Equation. Therefore, g of x is equal to negative 2 over x plus 1. Sorry, plus 2 plus 1. And that's your g of x graph. And as you can see, that's negative, so it's lying in quadrant 2 and 4. Is that correct? And then the question says, the last question, for which value of values of x does g of x increase? So firstly, is this an increasing or decreasing function? It's increasing. As you can see, it's always increasing. It's increasing for x is an element of all real numbers. Now looking at this graph here, does this graph exist at x equal to minus 2? No. So it's increasing for x in all the values except for minus 2. X is an element of all the real numbers, but x is just not equal to minus 2. If it's at minus 2, the graph does not exist, so it's neither increasing nor decreasing. Okay. The bonus question, we are told that the circumference of a circle is double. So how do you calculate the circumference of a circle? Circumference of a circle is 2 pi, not so. The circumference of a circle is doubled in the ratio of the new area over the original area. So if the circumference is doubled, that means to say that the radius has changed. Not so. So circumference is doubled. How do you calculate the area of a circle? Area is equal to pi r squared. Area, the ratio of area of the new area over the original area. That would simply be, so the original area is going to be pi r squared so the new area. So if the circumference is doubled, I forgot how to do this. Okay, so the circumference is doubled. That's going to be, I'm just going to pause it before I waste a lot of time. Alright, so I think I started off at the wrong place. Right, let's go again. So the area of a circle is pi r squared. So the radius of that circle, of the original circle, is going to be area over pi, the square root thereof. Alright. So the circumference of this circle is going to be pi 2 pi. Okay? Just give you 2 pi. The radius is going to be the square root of a over pi. Okay, but if the circumference is doubled, twice circumference is going to give you 2 pi root a over pi times 2. Okay? No, so. Okay, sorry about this. So, this is backtrack here. Start again. So, we know that circumference, because it's two circles, circumference 1 is equal to 2 pi r1. Circumference of circle 2 is going to be 2 pi r2. Okay. So what we're going to do is, we're going to make r1 the subject of the formula. So r1 is going to be c1 over 2 pi, 2 pi. And then of course c2 or r2 will be c2 over 2 pi. Okay. However, we know that the second circumference okay, is going to be twice the circumference of the first one. So that's going to be double C. So in other words, the radius 2, the length of radius 2 is going to be 2 C1 over 2 pi. We can have answer of C1 over pi. Alright. Now the question says, what is the area of the new over the area of the original? The area of a circle, of course, is going to be pi squared. So it's going to be pi, your radius of the new one. So it's C1 over pi. It must be squared. Okay? And this is all over the original. Area of the original is going to be again pi times radius, which is C1 over 2 pi squared. So that is simply pi times C1 squared over pi squared. This is all over pi times C1 squared over 4 pi squared. Alright. So on top we got C1 squared over pi must be divided by C1 squared over 4 pi, which is times 4 pi over C1 squared. So of course that cancels. That cancels. So the answer is 4. So therefore E. I'm sure there should have been an easier way of doing it, but this is the way I saw it at the time. The full question paper memo can be found in the description box below. Okay. Sorry again about this question. I was just a bit mixed up there.